part 4, I think. Yeah. Building your own SQLite. So in the previous video, we left it here at stage 4. And the problem is, in this stage, we need to fetch data from table, select the values of column, and print those values. Now for this, we need a little bit of SQL parsing. And in last video, I said I'd read through this SQL parse package and figure out if we can use it. So I went through it. I did read the documentation. And it looks like it does not do anything useful for our purpose. I mean, it's a very good package, and I'm sure there are people who are using it to build really good stuff. It's just that it is not useful for us. It can tokenize SQL, but that is not what we want. It will tokenize everything, and then we'll have to deal with those tokens, decide how we want to build a logic on top of that, right? So that will be unnecessarily complicated. At least in our case, we really don't need all of that, all those bells and whistles. We don't need to understand the query down to every keyword. In our case, we can afford some assumptions. So for example, one assumption is that this query is always going to be select, and we know it is going to be a valid query. At least there are going to be things in this query that we can target very precisely. For example, we know there is going to be a table name as the last keyword. We know there is going to be a column name or multiple columns, right? So there are some assumptions that we can make, because that is how the tester is going to test this whole thing. And I think for that purpose, it is better if we just, deal with this ourselves. We don't necessarily need this SQL parse package. So I'm not going to use this. If you want to use this, if you think it is simpler, easier for you to use that package and parse SQL and build your logic on top of that, then sure, go ahead. I just don't see the value. Right. So in this one, we need to read the data. We need to jump to the table page, then read the data. The data is stored in record format, and the record format is, I think we went through this briefly. These are all the serial types and content size and their meaning. So if serial type is 0, then the value is null. If the serial type is 1, content size is 1, then the value is 8-bit 2's complement integer. Then there are some of these slightly more complicated data types. If it is greater than equal to 12 and even, then value is a blob and n minus 12 by 2 bytes in length, something like that. So we'll implement all of these, or at least as many of them as we are going to need. And yeah, that's that. We already know the SQLite schema table. We already know there is a create table statement stored in it on SQL column. So we know all of that. Let's just get to it. Okay. So we will be given a query. And actually, we already have a case where we're assuming that if the command does not match Debian for table, then we'll assume it is a query and will act accordingly. Now we need to figure out if it is this query or that query. So now there are going to be two distinct queries. One is count star, and the other one is select some column from this table. So far, we are assuming it is count star, and we are just picking the table name. And since we don't have any parser to parse the query and understand what it is, let's do something about that. So we need some kind of logic here that will say if command dot lower dot also strip it, strip dot starts with select, actually if not Then we'll raise an exception here. Invalid command, whatever, right? And beyond this point, we can just assume it is a valid query. Does not really matter. We know it starts with select. So that is how we are going to deal with it. Now we need to parse this query. Let's write a function for that. Let's create a new function here. Say parse select query, and we'll be given some statement we need to deal with, and we'll return something. So what are we going to return? What information do we have in a query? I think the only information that is useful to us so far is column name and table name. Down the line, I think we will also need to deal with this where clause, but we'll burn that bridge when we get there. Let's deal with this. So we'll return something like, I guess we'll return a tuple with table name and a list of columns, right? We'll return something like this. And how are we going to do that? Can we just split everything on space and let me think. We can do that. We can just split it on space and but then what if there are multiple columns? Then we need some kind of actually let's deal with this using a regular expression. We're going to have a regular expression, something like it will start with select, then we can have multiple spaces, and then we'll have a list of columns here, and then we'll have one or more spaces. Then we'll have a from token, then one or more spaces, and then we'll have a table name, right? So something like this. Now I think table name is pretty simple. I'm going to use name capture. So that is our table name, and it is going to be alphanumeric, I think 0 to 9. I think underscore is also a valid character in table name. So yeah, I don't think SQLite supports hyphen dashes. I know Postgres does, but let's not worry about that. I think this is enough. So for columns, we are going to have alphanumeric, comma, and spaces, and as many as possible. Actually, there is a simpler way. I think we can just say, again, this is going to be a named capture group. Screw this. Column is anything that is not followed by from. How do you do negative look ahead? I think this is it. Let me look that up. Actually, not Python. Negative look ahead is question mark bang. Question mark bang. Right. So, and this is a capture group again, named capture. All right. So what we are saying in this regular expression is there is a literal string that is select, then one or more spaces, then capture everything that is not followed by literal from, right? So it will capture column names, comma, and spaces, and it will leave us at the last space. So then we'll consume all of these spaces. and we'll match from literal. I will say you'll see literally this, and then there are some spaces, and then we know there is going to be a table name, right? Let's also import RE. So now we'll say matches is RE dot find all and find iter. I think we'll use iterable. And it takes pattern, string, and flag. So a pattern is a regex, a string is going to be a statement, and flag, I think we need ignore case. Yeah, that is ignore case. That is all. So now we have an iterator that is going to give us all the matches. And we know there is going to be only one match. Actually, there are going to be, strictly speaking, there are going to be three matches. One, this whole thing will match exactly. Then there is going to be this and this. But what we are going to get back from this is, where is it? Okay, I can't find the type. But, well, let's just say that is not how you deal with this. We'll pick first match only. So we'll say next matches dot dictionary group dict. So group dict is going to return these named captures, column and table, and that's the only thing I guess that we are concerned about. So table name is going to be match table. That's what we are calling it, and then our columns is going to be match columns. Then we can split that on comma. Actually, let's strip that first. Strip and split on comma. So we are going to get every. Actually, column names are going to be. We also need to strip all of these individual column names. So we'll do something like return table name, and we'll map lambda x dot strip, and we'll give it a columns, right? So it will strip every column name and return a list. So that is our parse select query. We'll test it in a bit. Let's also look at our, we need another one. We need to parse create table statement also, I guess. Yeah. Statement. Right. Again, same deal. We will use a regex, we'll extract the matches, and then we'll deal with that. So our regex, we are going to have some regex, then we are going to have some, sorry about that, matches, re dot find iter, so regex and our statement and our ignore case. Then we are going to have, are we going to have only one match? Not sure. Let's find some test data, right? So what kind of queries can we have for create table statement? One is your simple create, don't worry about spelling. I'm not going to correct every spelling in this comment. Create table, table name, and then we are going to have column 1, column 2, something like that. We can have create table, table name. We can have this kind of structure. So we'll say column 1 int, column 2 int primary key, column 3 int, and then this. Or we can also have something like this, I guess. Yeah, so I mean, the formatting will change. But how many matches are we going to have? So there is our table name. We'll capture table. Actually, we don't even need to capture table name because we already know that we are going to parse the SQL for this table, and therefore we already know the table name. But I guess we have this information, so it will help us pattern match. We'll do that. Then we'll match column name, something something followed by a comma and new line. That is not possible because then you have this kind of column definition. You don't have types, and you don't even have a new line. You might even have something like this. I mean, I think it is doable by with regular expression, but again, let's go easy on ourselves. We'll extract this thing as one chunk. So, it will match everything that inside these this pair of brackets, and then we'll deal with this in Python. We'll split this, clean it up, and pick the column names, similar to what we're doing here, something like that. Okay, so I guess first we need to then convert this statement into something that we can work with. So we'll say, sorry, statement dot script dot actually no, not split. We will replace new lines with, say, a single space. So that way we won't have to deal with these different formattings. We can just assume that all of this is on one line like this, and yeah, I think that is easier to deal with. So now we can say in this regular expression, we will have create table and some spaces. Then again, we need this exact pattern. So that is our table name, and we are going to match that exactly here. Again, named capture. So we know what we are matching on. Then, so this is create table. We have all of that, and we are also consuming all of these spaces. Now I think this is a valid thing to do. Yeah. So we can't assume there are going to be spaces. So 0 or more, I think. 0 or more is star. And then there is a literal opening bracket and a literal closing bracket, and between these two brackets we have our match. That is going to be our columns, right? And that is going to be literally anything that matches. Let's see. So there is create table and table name, and then zero more spaces and literally opening bracket and then whatever and then literal closing bracket, right? Cool. Let's get rid of this. So I think there is going to be only one match. So we'll say match is next of matches, right? And then actually, what are we doing here? So this is, yeah, group dictionary, and our table name again is easy. I'll just say match table. That is our table name. Now for columns, we need to do something a little extra. We can't just use columns because column definition can have type, it can have other constraints, it might not have anything at all. So I guess we'll split on comma, and we're guaranteed to have a comma between two column definitions. So we'll split on that. That means that will give us one element per column definition, and then we can split that on space and pick the first value, I think, and that should do it. So we can do something like columns is each dot strip or each in match. Then you have columns, I think it is columns, yes, column dot strip dot split on a comma, right? So this will give us, oh, so we can't just say strip, we'll say split it on spaces and give us the first one. We'll take the first one out of that. Okay, so columns dot strip dot split on comma, that will give us one column definition per item. Then we'll strip it, split it, and take the first one. Yep, looks good. Then we are going to return table name and columns. Cool. Okay, so now we have something. Why is this one highlighted and this one is not highlighted? Is there any? I don't see any error. Yeah, I think it just, oh, it is highlighted now. Yes, stupid ID. All right. Okay, so now we need to do something about we'll parse the query, we'll take the table name. We also need to know what kind of query it is. So we don't really know if there is a function call, for example, if it says count star, or if it is trying to select column. I don't think that matters all that much. So I'll just say table name and columns is going to be parse select query, and that is a command, right? Then if we have only one column, and that is a count star thing, if column length is 1 and I think starts with count this, then what? What is this? Got map instead. Parse select query. Got map. Oh, yeah, it is a lazy operation. So we'll convert that into a list. Now it knows the length. And cool. What was I doing? Yeah, so if it is a count thing in our column, then we'll say just print, whatever this information is. Let's extract that out into a function of its own. So we'll call it count table rows. We'll give it a database and table name. And I think simply we can just return db.page for table dot number of cells. Number of cells. Yep. And we can print that here. Count table rows, db, and table name. Else we'll assume that we need to select data for some columns, and the columns are given here. Actually, so the next one is read data from multiple columns, and I don't think it is going to make much of a difference in our code. So let's implement both of these at once. I mean, I think it is easier to implement both of these at once rather than implementing something for single column and then for multiple columns. It will be more difficult to implement something only for one column. That is what I feel like. Right. So else we'll say we'll have a table name. We already know that. And table So we have columns that are coming from our select query, and then we have some columns that are coming from our table definition. So table columns is parse, sorry, not select query, parse create table. Create table. That will be our, in our schema, we have table name. And on that we have yeah, that is a dictionary, right? .sql. Cool. So this will return table name and table columns. Now we know table name and table columns, and we have function count table rows. So I think let's create another function, call it read table rows, load table rows, I think is a better name. This will also take a db and table name, and then we'll say, actually we're already doing this somewhere around here in database. We are already doing this. So we'll read page header, find the cell pointers, jump to cell pointer, and read data. Right. So I think this can be refactored and then we can use the common logic in both of these functions, but let's not worry about that for now. Let's just do this. So we are going to have a page header that will be our db.page for table name. Then we'll have some cell pointers. I think I'll just copy that. Yes, something like this. Actually, let's copy all of this. Why not? So we don't have self.handle, we have db.handle. Yeah. Also this, okay, we also need the columns. Number of columns, I think. Number of columns for this load table rows. Where is it? Oh, we are not using it right now. So cell pointer, we have cell pointers. We'll seek to cell pointer, read number of bytes in payload, read row ID, read record, and this 5 is going to be num columns. And what do we need to do? I don't think yeah, we can just collect all of this. We don't care about each individual value in that thing. So values is a list, and we'll say values dot append this, and then we'll return values. Actually, let's get rid of this and this. So now we have load table rows. It takes database handle, table name, and number of columns. We'll do the exact same thing that we're doing here. Yeah. Cool. So let's use that. Now we are going to have so we'll call this, we'll get a list of tuples. Each tuple is going to have column values in that order. How do we use that here? So rows are going to be load table rows. Load table rows from DB for table name, table columns. I think that will be length of the columns. Right. For each in rows, we need to pick only these columns. And how do we know that? How do we know what that value is going to be? So we'll have another list to select for in columns. I think we need index of that to select dot append is going to be table columns dot index of this column. For each in rows. There is another result. I don't think we need result. We'll just say for each in rows, for C in to select, we'll just print. Actually, we need to collect these values, append from each C. And now we have the values of all of these columns in our values variable. So we can just say print that I'll concat on a comma, showing all of these values. Let's see. So parts create table for our table. We're giving the SQL, get back table name and table column, table parts create table, table name and table column. Then load table rows, we get back a list of rows. Each row is a tuple, and in that we have the values of each column. So we need to select only specific columns. So we say to select is an empty list, and then whatever columns we need to select, we find the index of each column in our table definition, and using that index, we select the value from our returned rows and print all of that. So for each row, we'll collect the values from each column and then also print it. Nothing complicated. Right. Let's try this. No such file or okay. Key error columns 94. What is a 94? Columns. What are we calling it? Column. Okay. I think we can call it columns instead of column. Bytes like object is required, not string. Line 99. Bytes like object is required, not string. What? What? So the on this is on line 99 in parts create table statement equals statement dot strip dot replace. Replace new line with empty space. Bytes like object is required, not string. What the? Is it talking about this? I'm pretty sure replace is. I mean, we are trying to replace. What is going on here? Why? Statement equals statement dot strip dot replace. I'm pretty sure this is correct. Parts create table db schema table name SQL. We are giving it the correct thing. Bytes like object is required, not string. Ooh. This is a. Oh, that's interesting. Let's see. Unhandled serial type 10. 10 is not supposed to be a thing. I mean, we are not expecting 10. 10 and 11 variable reserved for internal use. These serial type codes will never appear in a well-formed database file, but they might be used in transient and temporary database files that SQLite sometimes generate for its own use. The meaning of these codes can shift from one release of SQLite to the next. And why do we have 10? Is a database corrupt? No, it's not corrupted. Yeah, it shows everything fine. Unhandled serial type 10. So either we are reading garbage somehow. Let's see. Parse create table, load table rows. So parse create table can have, it does not have any effect on our this function record parser. Parse record, and this is where the problem is coming from. So serial types, right? And we are given serial type and stream. Stream is fine. That is our database handle. This serial type is in serial types, and this serial type is coming from parse parent from database stream in range column count. Column count is just an integer, can't have any influence on the result. Parse parent is, we've been using this function. Yeah, so it has nothing to do with this. That means we are reading garbage. Not garbage, we are reading at wrong offset in the file or something like that. Right. So that means the problem is here, load table rows. Okay, we read page header, page for table. And this is also fine because we know this function is behaving correctly because we are loading SQLite schema table. Then we have some cell pointers, and this is all copied. We copied all of that code from. What the hell is there then? Load table rows to select append. I mean, at this point we are expected to have results. So everything that's wrong is in this. What? db.page for table did not change anything, right? You can see in the gutter there is no, I mean, this thing, whatever that is called. So that means we did not change anything in this page for table. It's been working fine. It is working fine even now. Cell pointers from byte. We're reading 2 byte per cell. That is giving the cell pointer, and I'm pretty sure that is how cell pointers are stored. So this is a record format. This is our the cell pointer array of a B tree page immediately follows the B tree page header. Okay, so we read page header. That means we seek to the end of the header. So the self.handle.seek, it is seeking to the beginning of page, parsing page header, and that way we are seeking to the end of the page header, right? That means after this line, we are at the end of page header. So now we are trying to read cell pointers. Let k be the number of cells on the B tree. The cell pointer array consists of k 2-byte integers, integer offsets to the cell content. The cell pointer array consists of k 2 bytes in 2-byte integer offsets to the cell content. What does this mean? Offsets to the cell content. Cell content is offsets to the cell content. Does this mean the offset begins from the starting of the cell content area? The 2-byte integer offset 5 designates the start of the cell content area. Cell pointer array consists of k 2-byte integer offsets to the cell contents. I mean, that is how, that is what I understand from this. Integer offsets to the cell content. But what's going on with this table then? How are we able to read this? Page header, let's see. So you give it the database handle, it calls load header. First 100 bytes are database header. That means we are at 101 now. And then it reads page header. Page header and cell pointers. For cell pointer, just seek to that position. This is our okay. Where's our hex editor? Hex friend find. Okay, so we have our page size that is 4096. This is the rest of the header. Page type, then free block, number of cells. This is 3. Content area is 3779. It says content area is 3779. Cell 0 at location this 3983. Content area is 3779. If you jump to that position, 3779 puts us here. And I think that is only because this is page 1. So they no. The cell pointer array consists of k 2-byte integer offsets to the cell content. Cell content. Content area is this 3779. Interesting. So our content area is at 3779. First cell is at 3983. Second one is at 3901. Third one is at 3779. Okay, so it is inverted. That is fine. So 3779 and says content area is at 3779. So this is the content for our first table. What about the other one? What about this one? Let's see. We have, where is our apples table? This is apple. Let's look at the file header then. Sorry. Record header, I think, is what I'm trying to say. Record format. A record contains a header and a body in that order. The header begins with a single variant, which determines the total number of bytes in the header. The variant value is the size of the header in bytes, including the size variant itself. Okay. Following the size variant are one or more additional variants, one per column. These additional variants are called serial type numbers and determine the data type of each column according to the following chart. Okay, been through this chart. Um, hmm. Let's see. This is a record. Where is the rest? This is 3901. What about this? What about 8101? So 8101. Let's no, actually not 8101. I think this is yeah, I'm looking at the wrong thing. I should look in this pane. So 8097. What is the page number for Apple's table? Let's print that somewhere. Load table row page header. Let's print this page header. Page type 13, number of cells, start of content. Oh, yeah, we don't have page number in page header. We have page number in our SQLite schema. Okay. We'll print, sorry, not this, this. So page header, print page header, print db dot dump. I think we are already printing it in dump functions. So let's just do this. And give it this. What do we have? Actually, make this one big. Right. So we have page header for whatever that is. Apple's table, type table, name Apple's table, Apple's root page is 2. Root page is 2. Okay. So let's do this using our brain. Parts create table and then load table rows. We go to load table rows, db.page for table. Page for table, well, page number is 2. So 2 into 4096 is, what is that? 8192 minus 4096. So that is just 4096, right? Yeah. So then we jump to 4096 and parse from that. Okay. So now we are at 4096. Then we read 8 bytes. Then we read some cell pointers. Okay, let's go and take a look at 4096. What is that 4096? 4096, what is this? This is our table header. Sorry, page header. And the page header is, what the hell is the page header format? Pages. This is our database header. This is our, okay, page header is like this. 8 bytes of B-tree page header, right? First byte is the page type, so we should see 13. This is our first byte and it is 13. Then there are 2 bytes integer at offset 1 gives the start of the first free block on the page, or is 0 if there are no free blocks. So this should be 0 and these are 2 bytes, right? So 1 and 2 and it is 0. The 2-byte integer offset 3 gives the number of cells on the page. So okay, 2 bytes and I think we have 4 rows in this table, so we should see 4 2 bytes, 1 and 2, so that is 4. Yes, we see 4. That means we are in page header. Okay, so that is at 4096. That means we are at this position, and then we are reading cell pointers. Each cell pointer is 2 bytes. So this one, number of cells, and then 2 and 1. So in total 3. We can skip 3 more. 1, 2, 3, right? That means this is the start. Okay, 2-byte integer offsets to the cell content. 1 and 2. This gives us 4067. 4067. Okay, so this means this position should have the first record in our table, right? 4067. Let's jump to, actually, I don't even need to jump to 4067. I know it is before all of this because we are at 4096 right now, and there is nothing related to this table at that position. But anyways, 4067, let's go to that. 4067 is just some random position, right? That means if I say 4067 plus 4096, 4067 plus 4096 is 8163. Let's jump to that position, 8163. And yes, we have our data. Cool. Okay. Okay. All right. So that is how this one is working, because effectively there is no offset and you don't need to add or subtract anything else, because this is the first page and this is the first table. So the offset is not in effect at this point. But when you jump to the second one, all of a sudden the value goes from 1 to 2 and the multiplication value changes. I mean, multiply anything with 1 and it does not have any effect. Multiply it with 2, all of a sudden your code is not valid anymore. I mean, yeah, ridiculous. All right, let's see how to fix this. So this is a page number, page header. I think we'll return, actually we have page size already. So we'll do something like that. We'll say, we also need to fix this one, right? This one. Actually, I don't think I'm entirely correct. What if the page number is 3? One two two eight eight. We go to this. What is this? Okay. So we'll just skip how many? 2, 2, 2, 6, 7, 8. We'll skip 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. So this is our 8th byte, and after that we should have our first cell, that is 15. Huh. Then 12288 plus 15 is what? 12303. 12303. Yeah, I don't think I'm correct. So this is the data for apples table. This is the data for, I know, looks like oranges. Yeah, orange. What is this? I know what this is. Let's do the same exercise for our oranges table, right? Let's print oranges. This is number of cells. Okay, so this is our table apples and SQLite SQL. Oh, so that data is for sequence table? I don't know. Let's keep going. Let's focus on oranges. Root page is 4. Okay, so 4 into, can I just type some mathematical expression here? 4096 into 4. Yeah, it doesn't work. It is 16,384. Let's go to that. Okay, yeah, that definitely. Right. Cool. So we have our page number is 4. Root page is 4. So 16384 minus 4096 is 12288. 12288 is this, and we have something here. Let's skip 8 bytes again. 5, 6, 7, 8, and this is our first. Sorry, not this. This and this 2 bytes is our first cell position, that is 4064. If we jump to 12288 plus 4064, okay, I'm right, I'm correct. So let's say cell pointer self dot, I think, page size, yeah, page size plus cell pointer. This should fix our load table schema. Actually, let's try that. Yeah, it didn't work. Hang on. Seek to cell pointer. Is that page 0 or what is that page number anyways? Again, let me get back to this one a bit. Let's see if we are right about this. Page size plus cell pointer. Unhandled serial type 4. Okay, that's not an issue. We can handle that. So oranges. Let's make sure we are focusing on this one table because we've been working with this all along. Unhandled serial type 0. 0 I think is null. What the hell? Yeah, 0 is null. 4 is what? 4 is 32-bit 2's complement integer. Huh. Okay, so let's implement this. Let's implement that. Let's add that type. If serial type is 0, we'll just say return none. Is that the only one? No. Join values, expected string bytes found, line 165. Okay. We are close. 165 join values. All of these values are bytes. That's okay. I think each dot decode UTF-8 each in values. How about now? All right, that worked. Now, well, I should not be happy because there is a bigger problem, and the problem is that this thing is not valid for SQLite schema table for some reason. I need to look into that. Huh. Let's make sure. Oh, this is valid again. Granny Smith Fuji. Yeah, Granny Smith Fuji Honeycrisp and Golden Delicious. Looks like it is done. There is a dump function. I think I'll just leave that function. We might be able to use it later. And then there is a bunch of this and a bunch of that. All right. Pass. I know. Which stage is this? Fourth stage. Pass stage 4. None type object has no attribute decode. Select butterscotch from pistachio. None type object has no attribute decode. That means there is no let's enable debug mode and see what is it trying to do. Oh, creating test.db with table mango, select banana from mango. Parts create table, none type object has no attribute decode. That means this one. But why is this none? Line 151. $151 db.schema.table name select banana from mango. Okay, and from that you want to query. So okay, let's do this. Print database schema. So we have grep with SQL none. How is that possible? Oh, type is index. That's what. Right. So that means we have a problem here in our schema. Self.schema is this. So we need to actually, I think we can maintain two separate pools. One for index and one for tables. I will rename the other one later on. Maybe. If record 0 dot, I'll say decode is, I think it is called index literal. Yes. Index, then we'll put that in index. Otherwise, well, let's just keep it this way. Right? So we are storing index in a separate dictionary and tables in a separate one. And oh, sorry. Let's see. Huh. Expected exactly 6 lines of output, got 7. 7 because we are printing this additional line. And what was that? I forgot. Holy shit. We are printing, I think it is, yeah, this. Okay, stage 4, test passed, and let's go to code crafters. We are through. All right, so the next one is, what is this? Read data from multiple columns, and here's the output it expects. Okay, so we are joining on comma, and this one is joining on pipe. I think let's just finish this one also. What is the output? Let's do this, right? Actually, it just occurred to me that I can also test this. Select I. How many columns are there? ID, name, and color. So we'll say name, comma, color, apples. Yep, works. Which stage is that? 5th. So we'll say pass stage 5, push, and let's see. Very good. Nice. All right. Yeah, I think I'm gonna stop this video right here. It's what it is getting to 1 hour 20 minutes long. That's a very long video. And in the next one, we'll deal with filtering data and then full table scan and using index.